going to record this hour. I'm going to record this hour as opposed to next hour, so doesn't really mean anything. Just I feel like we're going to have a good flow in here. I can just feel the positive energy. So what we did during third hour was we covered these examples and the ones on the next page. And then people had a couple questions that they wanted to ask about from the homework from yesterday. So we're going to pick up with a couple of the problems that maybe people would have questions on regarding the homework. And that would be, again, solving these inequalities and representing interval notation. And the first thing I'm just going to start with is when you see this x squared, notice that it is no longer x to the first power. That needs to be a red light for you. You just say, my normal way of solving things is gone. Okay? You need to get rid of that. What do we start with by doing here? Factor to x what? Plus 4 and x minus 2. Good. Less than 0. And at this point, you have the opportunity to make a graph, or you have the opportunity to make a table. I'm going to go to the graph method because that's where most people wanted to go. And what numbers do I put on my graph?
-4 and 2.
Put a -4 and I put a +2. Good. So what shape does this make if I were to graph it? It makes a parabola. Is this a right side up or upside down?
Right side up.
It's right side up. So I'm going to draw a right side up parabola like so. And the language that we use in mathematics is we say if the parabola is above the x-axis, it is, so the p, positive. And if it's below the x-axis, we say that it is negative. So notice what we have here. Positive when it's above, negative when it's below. So this tells me how I should construct my answer. Are we wondering where it's positive or are we wondering where it's negative?
Positive.
Negative.
Oh.
Thank you. We are wondering where this is negative because we are wondering where this expression here is less than 0. So it is less than 0 here. So the answer lies between -4 and +2. Does that make sense?
Yeah.
There was a slight level of confusion on that?
Yeah.
Okay, what makes sense now that didn't make sense before?
I was cautious of the inequality of what way it was pointing.
Got it.
Instead of just assuming that it was greater than 0.
All right, good. The next one, I would argue that is the next one a parabola that's right side up or upside down? It's upside down. Sometimes negatives throw people off, so I would argue you can always get rid of a negative. And the way you can get rid of a negative is just multiply through by a -1. And when you do, you have a positive 2x squared minus 7x plus 5.
Ooh, yeah.
Switch the sign. So that's the thing. When you multiply by the negative, make sure you switch that sign. That's kind of the give and the take of the situation. Okay, this does factor 2x and x. And then what are my constants? -5 and -1. I believe that works. So my solutions are
1 and 5.
Yep, some people said, can they use decimals? Could you use 2.5? You absolutely can. I've got 5 halves and 1. I construct my graph. I mark 1 and I mark 5 halves. Sorry, that 5 got a little sloppy there. Still figuring out this pen issue. What shape does it make? Parabola, right side up or upside down?
Right side up.
Right side up. We determined that. We made it go right side up by multiplying by the -1. Okay, so got a right side up parabola like such. And again, this tells us we're positive when it's above. We are negative when it's below. Are we wondering where it's positive or are we wondering where it's negative? Positive. This symbol here tells us we're wondering where the parabola is above the x-axis. And it's above the x-axis from -infinity to 1, bracket, union, 5 halves to infinity.
So if that sign is equals to, then it's always both our brackets.
Brackets, no brackets on infinity.
Yeah.
Does that kind of help people carry over a little bit from yesterday? Okay. All right. Then let's move along to this type of example. We have these four, and the question is, what if, you don't have to write this down, I'm just writing it down for you guys. What if you don't know what the graph looks like? I mean, before we knew it was a simple parabola, right? I mean, that's a totally different situation now. We don't know what that looks like, do you? I mean, if you were to multiply that out, that would be x squared minus 6x plus 8 over x plus 3. And the fact is, that would take me a long time to tell you guys what that graph looks like. The truth is, if you want a little bit of an idea, it actually looks something like this. It has a vertical asymptote, and it goes like that on one side, and it looks like that on the other side. Are those the kind of graphs you want to start sketching? Because I promise you it's going to take about 10 minutes just to come up with a graph. So we have an easier method, and that is by making a table on a number line test. Graphing calculator, I like your idea, yep. But what if the graphing calculator is not available for us? It could be that part of the AP section of the exam, which you guys don't have to take, but in calculus where they don't allow the graphing calculator. Or you could be in college where the professor says no calculator is allowed in my class because people come up with simple answers that way. Any of your siblings go off to college and have that happen to them? I had a number of kids come back say that they have a college class and the teacher does not allow a calculator at all. So, but hopefully that won't be the case for you. So here's what we do. Very simple. We start by making a number line. Anybody want to guess what numbers we put on that number line?
-2, -4, 3, or 2, 4.
Good. We put -3, and I'm going to put the number on top, and 2, and 4. Are there any questions where I came up with those numbers? Okay. I'm going to organize my work into a table, and the table will have a certain number of columns. The number of columns is equal to that number, so there's 3 of those, plus 1. So I have 3 numbers up on top. I'm going to add 1 to get 4. So you have 4 columns. So make a table with 4 columns. And then the number of rows is the same as the number of numbers I have up top. So I'm going to have 3. And then on the side, I put x minus 2, I put x minus 4, and I put x plus 3. And this is just a way of organizing my work for my number line test. Okay? Maggie, I'm going to ask you to give me a number to the left of -3. To the left of -3. Any number you want, just make sure it's that way.
-6.
Good, she's got -6. So we're going to plug in that -6, and I'm going to test it with each one of these. -6 minus 2, is that positive or negative? It's negative. -6 minus 4. Negative. -6 plus 3. Negative. All of those came out to be negative, didn't they? And what this then tells us is if you plug in -6, you would have a negative times a negative divided by a negative. What's a negative times a negative divided by a negative?
Negative.
It is negative. So I didn't have to compute actual values. I just needed to understand positive or negative. Let's go to another one. Axel, can you give me a number between -3 and 2?
0.
0. Thank you very much. And so 0 minus 2 is negative. 0 minus 4 is negative. Okay, Callie, 0 plus 3 is
3.
positive. Very good. Good.
Sorry.
So I have 2 negatives, which is going to make positive. Would you agree that it doesn't really matter what's positive? What matters is if things are negative. Like negatives are what changes the value. Positive doesn't change anything. We try another value. Okay, Bryant, what do you want between 2 and 4?
3.
Good job. 3 minus 2, that is positive, whereas 3 minus 4 is negative, and then 3 plus 3 is positive. So will that result be positive or negative? It will be negative. And a number to the right of 4. If I pick 5, I get a positive, positive, and positive. That result will be positive. organize my work pretty quickly. Am I wondering where this expression is positive, or am I wondering where it's negative?
Negative.
Yeah, due to this, I'm wondering where it is negative. So therefore, I'm looking from -3 on over, because that's where I see this negative sign. I'm also looking from 2 to 4, okay? So the solution is from -infinity to -3, union 2 to 4.
Why is it able to be 2 to 4?
Yeah,
Because it feels negative.
Oh, yeah.
Oh, gotcha. Okay.
That's-
Now, if you were ever wanting to check your answer, just pick a number between 2 and 4. Suppose you picked 3, and you said 3 minus 2 is 1, 3 minus 4 is -1, and 3 plus 3 is 6. So 1 times -1 is -1, divided by 6 is -1/6. That is a negative value, so we know it works. Any numbers you choose within those intervals should work. Okay, what I would like you to do, so we're going to do this step by step to make sure that you've got things good to go. The first thing I'd like you to do is just simply make a number line here, and I would like to see if you can place the numbers correctly on top. Place them in the right order and place them on top.
Mr. Hans, what do you do with the -3x?
Don't worry about it. Well, so the x will produce 0.
So
Yeah.
it's just 0.
Just 0.
Okay.
Yeah, okay, cool. Okay, everybody have that for my number line? Got a -2 from this one. Got a 0 from the -3x. Got a 10/3, and I have a +5. I'm now going to make a table. Okay, how many columns should I have?
5.
5. And how many rows should I have?
4.
And out front, I put -3x, I put x minus 5, I put x plus 2, and I put 3x minus 10. Now what I'd like you to do on your own is see if you can come up with a testing for these. I'll do one with you, and then you do the rest on your own. I'm going to plug in a number to the left of -2. I'll plug in -3. And -3 times -3 is a positive. -3 minus 5 is a negative. -3 plus 2 is a negative. And 3 times -3 is -9, minus 10 is a negative. So I can see here I have a positive and 3 negatives. That will create a negative output.
Like, I'm just kind of confused. Like, I don't get how you're getting this.
Everybody start filling this out the rest of the way, and I'll answer that question, okay?
I don't know how you give me that help or something.
So,
Yep.
x plus 2, what would you plug in to make 0? -2.
Okay, yeah.
So that's why I get -2. 3x minus 10, 3x minus 0, so 3x minus 10. That's equals to this. X minus 5 equals 0. And -3x will just open this up. Those are the solutions. Plug in a value, so we choose number, choose -2, 0, choose -1. -3 times -1 is positive. -1 minus 5 is a negative. -1 plus 2 is a positive. 3 times -1 is -3 minus 10. So if you were to multiply 2 positives and 2 negatives together, they will come in even positive. A little bit better? Okay.
It's two positives or two negatives.
If it's anything,
Did you come up with the same table that I did? Are we wondering where this is positive or are we wondering where it's negative?
positive.
We're wondering where it's positive. See if you can write the solution set. See if you can write the solution set. Is that what you wrote for your solution set? So this is the last part that really kind of makes today a little bit more involved. So please follow with me because there was a little bit of frustration about this third hour. That's not absolutely correct.
What?
And here's why. Okay, so lean in as we talk about it, and hopefully this will make clear sense. Why did you use brackets?
Because it's greater than or equal to.
Because you saw the equal sign. Good job. Everybody good with that? Now, I want you to understand, is it okay to have 0 in a numerator?
No.
Can you have 0 divided by 5? Is it okay? You can. 0 divided by 5 is? 0. Can you have 0 in the denominator?
No.
No, that is undefined, right? So I want to be clear that right now this language is saying that you can plug in -2. If you plug in -2, aren't you getting 0 in the denominator?
Yeah.
So while it says to use brackets, you can't use brackets on something that would give you 0 in the denominator. And notice that the two things that produce 0 in the denominator are -2 and 10/3. So that would be a half a point on the test. If you see the equal sign, just be aware that you can't include something that would produce 0 in a denominator. It's a little subtlety.
So you just have to check to make sure.
Yep, just check to make sure.
So then would it just, so then you would only have to look at the numbers that are in the denominator?
Yes, the denominator is the only problem. One last piece I'd like to show as you look at this is notice how the -3 is out front. If you had wanted to, you could start by multiplying this thing all through by -1. And if you did, it would change it to a positive 3x, x minus 5, over x plus 2 times 3x plus 10. But what would change? What would change? What would also change if you multiply by -1? It would then change to less than or equal to 0. And you would come up with the same solution set, but your work would look a little bit differently. So just be aware of that, okay? All right, you're ready to put it all together, okay? Good work. This is not easy, which is why you have a whole day tomorrow to be able to look at it and work on it, because, yeah, it can be challenging. Fortunately, you're very smart. Just think how tough this class would be if you weren't. Okay, what's different about the next one? Yeah, and so the first thing we must do is we must get it greater than or equal to 0. We like to compare to 0. So I have a 4x over 2x plus 3 minus 2 over 1 is greater than or equal to 0. Notice that the previous problems we did, they were all written as one fraction, weren't they? So we'd like to get this to be a fraction as well. So in order to get it to be one fraction, what should I do? Common denominator will be 2x plus 3. So I have a 2x plus 3, and I have a 2x plus 3. This is where people are making mistakes on their assignment, is in adding and subtracting their fractions. Let's look at what we have. I have 4x, and then is it plus 4x or minus 4x? Minus 4x, is it plus 6 or minus 6? Minus 6. That's where people are making mistakes. Not with the new table piece that we covered, but with their fractions. Greater than or equal to 0. What do you notice?
4x's cancel each other out.
4x's cancel. I get negative 6 over 2x plus 3 is greater than or equal to 0. Now, I would encourage you to always make it so that you have a positive up there instead of a negative. So I will multiply by a negative 1, and I will get a 6 over 2x plus 3, and that's less than or equal to 0. Thank you. This I forget that this is a question. Negative 1 is equal to negative 1 over 1. It is not equal to negative 1 over negative 1. When you multiply by negative 1, you only multiply the top or the bottom. So you do not multiply both the top and bottom by negative 1. Okay, does that make sense? All right, so there we have it. Now, when is the top equal to 0? When is 6 equal to 0? Never. So you don't need to put anything on the top for the 6. When is the bottom equal to 0? Negative 3 halves. So negative 3 halves is the only marking I need to put down. The top is never equal to 0. How many columns will I have if I have one term up there?
2.
I just make 2 columns. I have 1 row. I put 2x plus 3. And I test. What's the number to the left?
Negative 2.
Sure. 2 times negative 2 is negative 4. Plus 3 will give me a negative. And I'm going to use Axel's advice. I like to plug in 0 when I can. I do 0 plus 3 is a positive. Notice this gives me a very nice output. I just have negative and positive. Am I wondering where it's negative or am I wondering where it's positive? Wondering where it's negative because we're wondering where it's less than or equal to 0. So that would be from negative infinity to negative 3 halves. Do I put a parenthesis or a bracket?
Parentheses.
Why a parenthesis?
Because if you plug it in, it means 0.
Right. Notice the equal sign says use a bracket, but you can't get 0 in the denominator, so we use a parenthesis. Good job. All right, last one. I subtract the 3x. Now what? Common denominators. I'll multiply the top and bottom by x plus 1. I have x. And then what? Plus or minus? Minus by 3x squared. And then will it be a plus of 3x or minus of 3x? Minus 3x. All over x plus 1. I gather my terms together. Negative 3x squared minus 2x over x plus 1 is less than 0. I don't know about you guys, but I'd like to multiply through by a negative right away. You okay?
Yeah.
Again, you only need to multiply the top. So I get a 3x squared plus 2x over x plus 1 is greater than 0. And I have one more step. What's the last thing I need to do? Yeah, factor out the x, write it in factored form. And there I have it. What are the numbers that go in my number line? 0. I have a -1. And I have a -2/3. Those are all really close together, aren't they? Yeah. So we're going to have to use a little bit of number sense when we plug stuff in. How many columns will I have? 4 columns. How many rows?
3.
Some people grow to like the table method so often that they don't even draw the parabolas anymore. They just use the table throughout the whole test. And if you want to do that, you absolutely can. They're like, I like one way and I'm going to use it. Okay. What number do you want to start by plugging in?
-2.
Okay. -2 gives me a negative, and a negative, and a negative. 3 negatives will result in a negative. And now here's where some people's kind of mathematical sense, number sense starts to lose a little bit. We got -1 and we have -0.6 repeating. So I asked them to pick something. A lot of times people go for a fraction right away. I think it's just a lot easier to pick a decimal. You guys okay with -0.9? So -0.9 is negative. If you have to use a calculator on this, you're gonna have to. 3 times -0.9 is -2.7. And -2.7 plus 2 is 8 negative. And -0.9 plus 1 is a positive. If you were to pick a number between -2/3 and 0, what would you pick?
What?
What would you pick?
Between
Oh,
1.
0.
Well, for 1/2. Okay, thank you. -1/2. Okay, and I actually, that's fine. I like to pick -0.1, and you get to choose what you want. But I like -0.1, and I get a negative. The reason why I like -0.1 is I find it very easy to multiply by. But if you chose -1/2, that would work. 3 times -1/2 is -1.5. Plus 2 would be a positive. And whether you use -0.1 or -0.5, when you add it to 1, you do get a positive. And then when you move past 0 and you pick any positive value, these will all be positive. So you get this nice looking table where you have a negative and a positive. We've sorted through our work. You may get used to the idea that the sign changes all the time. That happens most of the time. It does not happen every time. Are we looking for it's positive or are we looking for it's negative? Yep, you look at the last piece that you're working with. It says, where is it greater than 0? So my answer is from -1 to -2/3. Union with 0 to infinity. And so to get to Ethan's point here, Ethan, if you were to sketch that graph on your calculator, you would find that it would look rather silly, but you would find that it would be below or above the x-axis during that span and then during that span. It might be challenging to see, but you would see it. Good job. I need you guys to get a graphing calculator. Did I mention that?
Yeah.
Okay. I have rental forms. If you want to rent one from Miss Hanson, they're $20. But by the beginning of next week, we're going to be ready to start teaching you how to use your graphing calculator. Okay. So I've got rental forms if you need them. You have a little bit of time here to ask questions. You have a full workday tomorrow where you can ask questions about this. The answer key is posted for 2 parts. This is the calculus, or no, this is the algebra one. Right there you go. And then somebody grabbed my recent one. I just posted the one for today. And I'll post that right now.